So one quick thing before we get started. If you have a Friday Shoot Lab, there's a public holiday this Friday, so they're not running. There are catch-up ones happening right now. If you want to go along to one of those, I've put the details on the course website. There's one running during today's lecture and tomorrow's lecture. So if you're in a Friday Shoot Lab, feel free to leave the lecture now and go to one of those. Otherwise, you can go to any other Shoot Lab that suits you during the week. I won't be offended if you leave now. Okay, so hello and welcome back to COMP1511 18s1, the lectures. Today's lecture, we're going to look at something new called strings. Didn't get that up. So the overview, thank you. Can I grab your charger as well? Thank you, tutors are great. So the overview for today's lecture. After this lecture, and again, you'll know what these mean by the end, you should understand the basics of chars, or characters, understand what ASCII is, understand the basics of strings, and write programs using strings to solve simple problems. So, thing number one, don't panic. It's week 5 now, right? So there's a lot of stuff going on. A lot of stuff going on, but please don't talk about it now. So a lot of stuff going on in the course and in your other courses and everything. Like we've got the assignment at the moment, we've got the labs every week, the tutes every week, the weekly tests every week. So it might feel like a lot, but don't panic. You'll get there. How many of you, out of interest, were new programmers at the start of the course? So at the start of this course, you'd done either no programming or a little bit of programming. Okay. How many of you are now feeling sort of okay about programming? 2 of you? Okay, so I really hope that over the last couple of weeks, you've started to kind of get into the swing of things. Hopefully things are starting to make sense. I know in this course or in learning programming, people often find they're fine and then they hit this one topic and everything gets really hard and then they can't do it anymore. So that's very normal for that to happen. If you feel like you've gone, oh, this is all good, but a raise, man, I can't get a raise. Don't panic, that's normal. We have these help sessions every week, multiple times a week. Fantastic tutors in a room for many hours just to help you with any questions you have or any problems you have. So if you're finding anything hard, go to the help sessions. They'll be great. I will also be appearing in some of the help sessions at random, so if you want to see me, go to all of them and you might see me. And I'm going to try and schedule some consultation hours, so outside of lectures, somewhere for you to ask me questions. So that's help sessions and not panicking. The course style guide is published. How many of you have actually read the style guide? Okay, so that's like not very many people. I very highly, thoroughly recommend go home tonight and read the page and read the parts that are relevant. Read the stuff on indentation, the stuff on arrays, like the topics we've covered so far. Do that thing. The weekly test for last week is due on Friday of this week. How many of you did the weekly test last week? Andrew Taylor said that everybody did it apart from like 2 or 3 people, so I hope you all did it. Hopefully you found that okay. Next up, assignment 1 is out. We released it on Wednesday last week. How many of you have been working on the assignment thus far? That is a very small number of hands. Shh. Shh. So those of you who haven't started yet, please shh. If I do it effectively enough. So if you haven't started on the assignment yet, please do start very soon. Go home tonight. Read through the specification because you will have questions. One big part of any computing project or computing assignment is trying to understand the thing itself. Do the necessary research and all of that. So you can't do that the night before it's due. And if you have any questions about the assignment, ask them now. If you ask them 15 minutes before the assignment is due, we won't be very happy to answer them. I mean, we might, but don't do that. One more thing, we have added more auto tests to the assignment. So there were some common problems. I might actually open that now. How many of you have read the assignment specification? That is such a low number. You're going to make me cry. You don't want to make me sad because then I'll give you bad marks or something. I don't think it works like that. I would never do that. Oh yes, I forgot that the website is always slow. Everything is always slow. Is this one slow? Yes, it's loading. Assignments. Assignment 1. Okay, so assignment specification. If you haven't read this, I am 100% serious. You must read it tonight. Like, unless your computer catches fire, and there are no other computers you can find, and your phone catches fire tonight, then that's the only reason not to read it. So whatever you do, just read through this tonight. One thing that has been added, I added colors for a start. I like the colors. I hope you like the colors as well. But I've changed this section. I haven't changed what you have to do, but I've added more clarification and I've restructured it more. I'll zoom out so that you can see the restructuring. That doesn't actually help at all, does it? But you must use the provided hash defines in your assignment. You cannot say if town equals 0. 0 is not a meaningful number here. You must say if town equals town Adelaide. You can't treat them as numbers. You can't say if something is less than or greater than a hash define. So you can't say, you know, if the town is greater than Auckland and less than Wellington. Basically, you need to imagine that they don't have any numbers at all. They're just words that you can use. It's invalid to compare if it's less than a hash define. It's fine to compare if it's equal to a hash define. Basically, the only thing you can do with the hash defines is compare if they're equal. And you must use the hash defines and not their numbers. One thing that you can do to check if it's a valid town, like if it's within the range of towns, that's fine to compare to the number of towns you have. So this is separate to, this is checking if it's a valid town rather than checking what town it is. But please do not use hash defines as numbers with less than and greater than. Please do not use just the numbers. We've added some auto tests to catch this out. So if you submitted your code before we added the auto tests, your code should still work. I think there were like 2 or 3 people who'd submitted code that didn't follow this. So the auto tests will tell you that. Another requirement, am I talking too fast, by the way? If I'm talking too fast, raise your hand. Okay, only a couple of people. I'm gonna hold this in front of me. Talk slowly sign. I'm a bit frantic because I was running late and everything was broken and I get frantic. So additional functions. This was not explicitly written before. It is now explicitly written. It has always been a requirement implicitly. You must create your own additional functions for this assignment. You cannot make this assignment in just the one getLocalTime function. That is not going to be okay. If you didn't do this, you would have lost a lot of style marks because you can't write good code that's all in one function. Like you can't write good code that's more than a couple of lines long. It's in one function. If your assignment implementation is one function that's 300 lines long, just no, that's bad, don't do that, okay. And something that was raised on the forum, person who asked on the forum, thank you, it's a good question to ask. Is it okay to make functions that are only called once? The answer is yes. I say it's okay, yes, you are allowed to make functions that are only called once. Go forth and do it, but like, make functions that make your code clearer, right? So if you're going to have a function to get the input, call it getInput, that's fine. Call it once, put the logic over there. I'm rambling a little bit. Read the forum, there are great answers. Make functions. Check that the parameters are valid. Don't use any of these things. I've also added a changelog. So if you read the spec, you can see at the top when it was last changed. So if this date is later than when you last read it. If you read it at a time before this date, then read it again. And down the bottom, it tells you what the things that were changed were. But again, there shouldn't be any major changes to anything. The only changes that will be made are things like clarifications, explaining something in more detail, and if there's typos to fix or anything like that. We won't be adding any like major additional requirements. The assignment itself won't change, basically. Cool. That's enough assignment stuff. Are there any questions about this before we move on? Okay. let's move on to something new. So thinking about variables, right? We've only really seen numbers so far. So we can store ints like age is 18, doubles like pi is 3.14, so floating point numbers, not whole numbers. But that's really limited in scope, right? What are some other things we might want to store? I think I asked you this back in like week 1 when we looked at variables for the first time. Can anybody think of anything else we might want to store? Yeah, someone said strings. What is a string? What do you mean by strings? What do you mean by characters? I'm sorry, I'm asking you a very hard question. We might want to store something like words, for example, or text, or letters, or whatever you want to call it. And conveniently enough, we're going to learn that today. We also might want to store like more complex things. Anything at all that you can imagine we might want to store. Maybe not like people, but like anything you can fit in a computer that you might want to store. We'll look at that in future weeks, but this week we are looking at words. So I assume that you all understand what a word is, right? Like a word is some letters like Andrew. You can have a collection of words like Andrew is awesome. And you've seen printfs like this before, maybe not with those words, but you've hopefully seen printfs like that. This will print out Andrew is awesome. And this thing in the quotes here, Andrew is awesome, is what we would call a string. So a collection of words in C is called a string. Introducing strings. So when we have a string, it's just an array of characters, and we'll look more at what that actually means. A character, I looked it up on Google to get the definition. It refers to like a printed or written letter or symbol. So we might say like H is a character, speech mark is a character, full stop is a character, space is a character, like any sort of letter and number we would refer to as a character. Oh, look, I had that right here on the next slide. So letter, number, punctuation, and so on. And in C, we refer to it as a char. So char just means character. So you've seen ints. Hopefully you're feeling pretty good about ints. Int age equals 18. Chars are another type. So we replace the word int with the word char to say the type. We give it a name, so letter, for example, equals a inside these single quotes. So whenever you have something inside the single quotes, like just the one quote, that becomes a character. It's important to differentiate this from strings like we have in Printf, which have double quotes. So whenever you have lots of letters, you have the double quotes, and whenever you have just the one letter, you need the single quotes. So char in C is a small number, basically. It's smaller than an integer. It can store a smaller range than an integer can store. It's almost always 8 bits, and you might remember 8 bits makes up 1 byte. Whereas ints are normally 32 bits, which is 4 bytes. And so a 32-bit number can store numbers that are like this big, up to 2.5 billion-ish. A character can store numbers that are this big, which is up to about 128 or 256. These are used to store ASCII character codes. Again, wait for a second, we'll talk about that more. But something important to keep in mind, don't use these for variables, just use them for arrays of characters which are making strings, and only use it for characters. If you want to store a small number, don't store it in a char, store it in an int. Ints are for numbers, chars are for characters. And so, this thing called ASCII. Does anybody know what ASCII stands for? American Standard Code for Information Interchange. Don't you normally sit over that side? No? Your voice sounds like that side. Anyway, ignore me. So thank you. Yes, ASCII stands for the American Standard, sorry, what was the C? Code for Information Interchange. What this actually translates to, it's a way of mapping numbers to characters. So when we store things in our computer, right, when we store things in memory in C, they're numbers. Like, if we go at a deep enough level, they're all just zeros and ones. So we need some way of representing characters with these numbers. And there were originally all these different standards. Everybody made up their own rules. So, they might have said, 1 is A, 2 is B, 3 is C, and they might have said, 10 is A, 10 is B, we'll have the punctuation first, and so on. So ASCII is a standardized way so that everybody can talk to everybody else with the way that their letters are encoded. ASCII specifically can handle English letters, so capital A to Z, lowercase a to Z. It can handle digits. 0 to 9. It can handle some common punctuation symbols, so basically everything on a keyboard, like comma, full stop, slash, basically everything on a keyboard. And special non-printing characters like newline and space. Space is a printing character. I copied this from Andrew Taylor. He's wrong. Spaces, you can see spaces. Anyway, but things like newlines, you know, when you type the \n in your code, it represents a new line, which is like going to the next, you know, go to the next line, that sort of thing. And again, there's an ASCII character to store that, because that's a thing that we might need to store in our programs. Something important, you don't have to memorize these. There will never be a test on what does the ASCII code 65 stand for? It's A. What does the ASCII code 50 stand for? It's going to be 2. That will never be tested. You can always get the ASCII codes with these single quotes. They've gone to curly single quotes, but like when we do this single quote, a single quote, printing it out as an int, it will give us the ASCII number. And please never use the ASCII codes in your program, use single quotes instead. Don't try and print out the number 65, print out the character A. And that's all a lot of talking in theory for me, it's all kind of boring, blah, blah, blah. Let's actually write some code. So let's make a program to print out an ASCII table. So let's start my program out by copying an existing program rather than typing it all out from scratch, if I can find it. There we go. You didn't see the answer. Cool. So when we write our programs, I did not mean to save that there. I have just overwritten the actual file. My bad. Okay, computers, they're very hard. Okay, whatever, got there in the end. So, thinking back to what I said just before, full screen, minimize, slides. We can print out with %d a character, so single quotes with a letter or number inside, and that will give us the ASCII code. And so I have promised you that this does this. And so we will find out. I think it turned the smart quotes into single quotes. That's a really important thing to keep in mind. I know a lot of keyboards, I think Chinese keyboards especially, will put in different full stops and different speech marks. So if you get some weird compile error in your code, I think this will hopefully give me a compile error. Okay, it is giving me a literal question mark, but you'll get some, if you have a smart speech mark, it'll look like a normal speech mark, but you'll get some weird errors or spat out at you like this. That's okay. If you ever see strange errors, keep in mind your quotes might be wrong. Okay, that one over there, this one over here. Can I like automatically hide this? Maybe not. Oh well. Cool, and so this is from these slides. I have said that when I print out A, inside single quotes, the character A, it'll give me 97, capital A 65, 0 the number, 48, and then space plus new line, which is going to be some ASCII character 32 plus 10 gives me 42. Let's compile this. Let's run this. Yeah, I guess it did. What's happened here? What's gone wrong here? Why is it printed out some really big number? Yeah, someone said no new lines. Because I don't have any new lines in my printf, it's going to print all the numbers separately, but with nothing between them to separate them, so we can't actually tell them apart. Is that font size still readable? People up the back, too small or is it good? Good? Too small? I'm getting some thumbs up. Is it thumbs up for too small or? Okay. If it's too small, just yell out or get magnifying eyes. So, ASCII table. prints out, as we promised, 97, 65, 48, 42. So how could we find out more of these numbers? How could we work out what all the various different numbers were? Any ideas? And let me look at the thing. Yeah. Okay, so you've seen printf, right? Printf, and we can print out, we have different sort of format codes for different things. So %d is for int, because d and int are the same thing. %lf is for double, because lf is clearly a sensible way to mean double. What do you think character might be? %c. %c, this is the only one that actually makes sense. C is for character. And so I can print a character, right? I can print the character capital A, and this will, hopefully, give me capital A. Print it out there. And I can print the number for capital A, so the ASCII value for capital A. So let's run this. Cool, so as I promised, this printf here, printf %c, capital A, has printed out capital A. And this one, print out %d, capital A, has given me 65. So this is showing me the character itself and the ASCII value. So the number that is the ASCII value, this is the number that it means in the memory of the computer. It's stored as 65, but it means the letter A. Does that make sense so far? Cool. Are there any questions thus far? Cool. So what if I wanted to see what the ASCII code for capital B was? I can just do this, right? A, B, C, D, E, F, G, A, B, C, D, E, F, G. So hopefully this will print me out the ASCII values for A through to G. Okay, and so we've got down here ASCII value for A, 65, 66, 67, 68, 69, 70, 71. What's the pattern with these numbers? Everybody said things and none of them sounded specifically loud enough. +1, yes, someone said +1, cool. So we can see that the number 65 and the number 66 is one more than that, and conveniently, B is one more in the alphabet than A. So all of the alphabet letters are stored consecutively in ASCII, so 65, 71. So what would H be? If G is 71, H would be? Anyone? 72, yes, one person passed primary school, thank you. Maybe, you learn adding numbers in primary school, I'm sure. And so we could type out all of the letters and all of the lowercase letters and all of the punctuation symbols, and then we could print them all out, and that would be really annoying. Shh. So rather than doing something by hand a lot of times, I could use a while loop. Yes. So if I want to do a very similar related thing over and over again multiple times, use a while loop. I'll get all this stuff out of the way, void do stuff. This is a not recommended but totally legit way to just get rid of code, is just put in a function, chuck it at the bottom. Goodbye. No one likes your code. So, loop. While something, do something, do something, 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 something. Okay, what do I need first in my loop? Initializing, yes, initializing my loop counter. I'll make it an int, what should I call it? I, good choice, equals 13? Nah, we'll start at 0. While what? I is less than something, end of ASCII values. What do I want to do down here to go to my next iteration of the loop? I++, perfect. And so what's going to go in here? Like, do the thing, right? So you'll notice something I did here. I don't actually know what the number for this is. I mean, I do, but you didn't know what the number was. So we can just chuck in a hash define, while I is less than the end of the ASCII values. And then this, the program says what it's doing. You don't need to know the number right now. You can work it out, you can Google it, you can make it be a hash define. I happen to know hash define, this is 128, because the last number is 127. I'll make it be that. So this would be equivalent, right, to having less than this plus 1, right, or this being 128. So it's equivalent in C in what will happen, like in the program doing the same thing. These two things down here will do the same thing. They will both run from 0 to 127. It'll stop when it's less than 128, 127, or when it's less than or equal to. Why have I done it this way? Why have I gone less than or equal to here and made this one be 127? I can tell you that the last ASCII value is 127. So I reckon the reason I've done this, well, hopefully I know the reason I've done this. To me, it makes more sense to go, well, I is less than the end of the ASCII values, and then this being the actual last number. And so less than or equal to means it will go up until the last number. Okay, and then what do I want to do in here? I want to print out an ASCII table, right? So maybe %d is %c. So I'll print out the number and I'll print out the character that it maps to. So the number is going to be, what number do I want to print out each time? I, yep, cool. And what's the letter that I want to print out each time? It's also I, right? It's I as a character. So this is maybe a bit confusing. This is sort of an important thing to be aware of. Types in C are sort of meaningless. And the people who like types are going to yell at me for that. So what I mean by this, C has types, and the types are there for the compiler to know when we're doing things bad with our code. So for example, you don't want to have this sort of type and this sort of type get mixed up. When we see pointers in the future, lots of bad things for type confusion there. But actually in memory, they're all just the same thing. I in memory here, if I've got A, we said A was equal to 65. And then in binary, 65, I think it'll be that. Of course it'll be that. I know my binary, I know my ASCII numbers. If you're in high school and you have no life, you could memorize the ASCII binary conversion and then learn to like convert binary to ASCII. It's paid off once in my life. I did an escape room and I didn't have to find a clue because I already knew how to do that. So great thing to do in life. Very, very valuable skill, you know, impresses everybody. But I happen to know that this is what capital A is like. And so I in memory is just going to be this. It's going to be this binary number. You don't have to know how to do this, by the way. You don't have to have been a weird kid in high school. But this is the same as this, is the same as this. In memory, it's all just zeros and ones. So the important thing here is how we interpret it, how we look at it. So when we print it out with %d, we're saying, hey, this is an int. When we print it out with %c, we're saying, hey, this is a character. And so when printf runs, it'll print out the number I, and then it'll print out I converted to a character according to ASCII rules. Do you believe me? Can I show you something cool? Let's say I is 65. Can I chuck a return in my program here and have it just not run my program? This is bad, don't do this. So I claim that this here will print out 65 and then capital A, right? I have 2 return zeros. That's actually okay. More on that in a minute. So you can see here, I wrote my program and it says 65 is A. Shh. So you know how I said it's all the same in memory and it'll just interpret it in a different way? What if I printed it out as a double? As a double, it'll give you this. What do you think this is going to print out? Who thinks it will print out some nice, sensible number? Who thinks it'll print out random stuff? Who has absolutely no idea? I think it'll print out some really weird big number, but we'll see. Okay, so it's telling me, by the way, like this is a double, not an int. Okay, that's disappointing. It just printed out 0. We'll look more at this later. But the way, according to the rules of how doubles work in memory, 65 and A are the same as 0 point, a whole bunch of zeros. Fun to know. I'll try and save all the intermediate versions so that you can look back at them later. Okay, and now open this one here again. Okay, back to what we were doing before, being good people without multiple returns. Go to those lines. Shh. Okay, so what I am hoping will happen here, I is going to start at 0. While I is less than the end of the ASCII values, print out %d is %c. So print out this number is this character in ASCII. And it's giving it the same, the I, the loop counter each time. So this will print out ASCII 0, ASCII 1, ASCII 2, ASCII 3, all the way through to ASCII 127. I wonder what this will do. I might do a thing. Ignore this line, we'll talk about this in a minute. We will talk later about what this means. I just think that I can do this now to make it only print one thing at a time. Cool. Go away. Clear. So what I've done here, you don't need to know this yet, we'll look at it soon. I've told it, wait until I type something in. And so it'll just sit there until I type something in and then it will print out the next one. So 0 is nothing, okay. 1 is a box with a 1 in it. 2 is a box with a 2 in it. Oh man. Oh, 5 is nothing. 6 is... Hang on, I got a beep there. I want to run that again. When you print out 7, you're printing out a beep. Did you guys hear the beep? It's very exciting. Cool, 8 is nothing, 9 is nothing, 10 is... 10's gone to an extra new line, so ASCII 10 might be a new line. 11 is nothing, 12 is also a new line. Interesting. 16... Hang on. 16 is 10, 17 is 11. Strange. Aha, we got some letters, we got some characters. 32 is, who knows, 33 is exclamation mark. 34 is speech mark, 35 is hash, 36 is $sign. So we can see the punctuation is all here at the start. Oh, and we've hit numbers now. Shh. So we can see here number 48 is 0, 49 is 1, 50 is 2, 51 is 3. We have semicolons, we have some more punctuation, we have some letters. Oh, some more symbols, and some lowercase letters. Even more symbols, and then this thing here. Cool. Is that cool? Was anybody impressed by that? Did anybody find that interesting and cool? I did. I hope you did. So what have we just achieved here, other than printing out some stuff and printing out a beep? That was pretty cool. What have we achieved here? So I would say one of the things we've achieved here is we've seen, like ASCII values are a number and a character are sort of the same thing. Numbers are, how do I describe this? Like when we have the number 33, it's just the number 33. But if we interpret it according to the rules of ASCII, that's an exclamation mark. So this program here is printed out following the various rules of ASCII, or following the, specification of ASCII. These are what all of the characters are. Okay. It's pretty cool, I think. Let me just see what I had planned next. GetCha. Okay. So, my next demos, I stole them from Andrew Taylor, but that's actually fine because we're both called Andrew. So it works out really well. I highly recommend, like, if you're going to be a lecturer, get your parents to name you the same thing as another lecturer for the same course. You can steal all of their examples. How am I going to do this? I'll grab this one here. Live. Okay, so shh. Remember how I said you should never print out the ASCII values and you should only ever print out them as characters? This is an example of not doing that. So printf %c and put char are the same thing. So printf %c, 65 is equivalent to put char 65. Can anyone think of a reason why we have this put char thing and also this printf thing doing the same thing? Like, why could that be a good idea? It's just more complexity, right? Surely it's bad. So I reckon printf %c 65 is like potentially confusing, right? We have to printf %c 65. We can look at this, we can go that's printing the character that's 65. But it's a lot of typing and it has to call the printf function. And printf is a very complicated function. I'm sure you can imagine printf does all these things, right? And the code for it is very complicated. If we just want to print one character, we can call putchar, and that avoids calling printf and printf doing all of its printf stuff, and this will just print out the character that has the value 65. Does anyone remember from before what 65 was? Capital A, yes, one of my favorite letters. Can anybody guess what 110 is? Lowercase n. Wonder what this is going to spell. If we look at our ASCII table, oh, I cleared it. If we look at our ASCII table from before, 110 is lowercase n. 100 is lowercase d. Going to guess that those are going to be some other letters, possibly spelling Andrew. So let's compile our Andrew Rocks program. Let's run Andrew Rocks 0. Print it out, Andrew Rocks. I would have said it's awesome. Different. So does this make sense? I have a program here. It prints out a bunch of numbers. Rather than using printf %c, it's using putchar. It's giving it a number, but that number is the ASCII code for these letters, and so it works. So it prints out this Andrew Rocks thing. Yes? Can you put them all on one line? What do you mean by that? Like no new lines between the putchars? Oh, you mean like this? Cool. So the question was, can we put them on one line? Like, can we just have putchar this, 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 and so on? My answer to you is, when you don't know something, there are several approaches you can take. You can ask somebody, like you've done to me. You can Google it. You could Google this. You can try it yourself and see what happens. So let's try it and see what happens. Can I do putchar like this, putting out multiple characters, printing them all out in one go like this? And the answer is, compile, no. I'll make that full screen and just look at that in more detail. So it's saying, error, too many arguments to function call, expected single argument, _ c, have 6 arguments. And then putchar declared here, expanded from macro blah, expanded from macro blah. How many of you have seen a compile error and gone like, this is confusing, I don't know what all this means? So those of you who haven't ever seen a compiler error that you don't know what it means, like that's, I'm impressed. I don't know what this means. I mean, I sort of know what some of this means. Right. One of the understanding compiler error messages, understanding any error messages or anything like that, it's sort of like an art form, right? The the key thing to learn now is how to find the parts that are important to you, the things that you need to know, and then ignoring the rest. So like telling this bit is important to me, this bit is not important to me. This bit here is important. It's saying like on this line of code here, something's wrong. All this stuff here doesn't really matter. Like you should hopefully learn to see this message and go, okay, we can ignore all this stuff, it's fine, this is the part that matters. And if you're not sure, one thing you can do is fix the one compile error that you can see and then recompile again. Often you'll find one error in your code leads to a zillion compile errors below, and it's sort of a flow-on effect from that one thing. Oh, but looking back to this, error too many arguments to function call. Expected single argument have 6 arguments. So the compiler is telling you the answer to your question. What is the answer to your question? Yeah, you can only have one argument. Thank you, compiler. It was a very nice message for you to tell us. And so the answer to that is no. And Char puts a single character. It prints out a single character to the screen. What is the next Andrew Rocks? So let's change this slightly. Save as Andrew Rocks 1. So instead of having the numbers, what could I do here? Like instead of the numbers, I can have the characters like this, right? A, N, D. Gosh, this is sure going to take a long time for me to type. Hang on, this is a space, right? After Andrew was a space. 32? 32 is the ASCII code for space. I'll leave that there. So this will print out the exact same thing as before. I'm just telling it now, instead of printing the number 65, print out the number 65, which I'm referring to this time as a character with single quotes. Compile, compiles, run, Andrew Rocks. I should have called it, oh, well, I didn't even compile it. I lied to you, I compiled the previous version. See, it does the same thing because I compiled the old file. Tricked you guys there. Andrew Rocks 1. Andrew Rocks. Okay, hopefully this makes sense. Are there any questions so far? Would somebody like to ask the question, can we take a break? Does anybody have a question? Yes. Yes, we can take a break. What a good question. So let's take a break for 10 minutes. Don't just sit down, make sure you stand up. I'm not lying, you should do the thing. Good, cool. Okay, hello, apologies for that brief delay. I broke my slides and they all, anyway, they do great things when you forget to close one of your tags. But yes, welcome back. I hope that you have had a good break. If you sat there the whole time and didn't stand up, I am disappointed in you, and you should really not do that next time, please. Don't make me sad. But thinking back to where we were, we just looked at printing out ASCII numbers and then the letters as ASCII with Char. So this one here. Another thing that we can do, we can read characters in. So we haven't actually looked at that yet, have we? So like we have Char, which will put a char, print a char out. We have GetChart, which will get a char in, surprisingly enough. Something important to note here is that it returns an int. So you can't just say char c equals GetChart or bad things will happen. If it can't read something, it returns a special value. Otherwise, it returns an integer, which is probably going to be an ASCII code. So let's look at... That's already Andrew Rocks. Cool. Still my main function, do the stuff here. So... Oh, hang on, I totally had an example on the next slide, didn't I? Yes, I did. Excuse my brief brain forgetting. So, GetChart, like I said, returns an int, not a character, so you need to scan it into an int. So if we say here, C1 equals GetChart, so printf, please enter the first character C1 equals GetChar, printf into the second character, C2 equals GetChar, print out the first and the second character numbers, right? So what should this do? What do we expect will happen here? We type in a character, or type something in with the keyboard and something else in with the keyboard. We expect them to be stored in C1 and C2, right? Hopefully that's what I just told you this does. What does it actually do, though? There is a problem here. Can I just paste? Yeah, excellent. So have a think while I put in some new lines into this. What could go wrong here? DCC, char1, char1.c. Okay, and so as promised, get char1. If I type in, let's say A, okay. If I type in A, B, so this isn't quite doing what I expected. I'll print them out as characters as well, so that you can see exactly what's going wrong. So I've just changed the printf to print out the number and also the character. Oh, gosh. Those are some strange values. I wonder why those are there. Yes, thank you to the people who said that. I haven't, so the error I have here, wanting more % conversion than data arguments, this means that you haven't put in enough variables here for the number of things you're trying to printf. Wonder what would happen if I ran that anyway. It would be interesting to find out. Let's try that again. Okay, so I'm going to enter in A, one of my favorite characters. And then I hit enter and it said, you know, type in A, hit enter to finish entering it, and then nope. So we can see it's scanned in the A quite happily. It's gone, the first character is A. The C1 here is A. But then the second one is 10. What character is 10, looking at what's happening here? Someone said space. It's the enter character, right? I've pushed enter, it's gone to a new line. We can see this is printed out, a new line. It's moved to the next line. So that's problematic. And I can't just get away from it by doing A and B because, no, it's scanned A, then a space. And I'm not following the instructions of entering one character. So what can I do to fix this? The problem I'm having here is it's scanning in my new line, right? So I run it, I type in my character. You'll notice that it doesn't instantly ask me for the next character. I don't know if I've talked about this yet, but when you print things out or scan things in, it waits until you've pushed enter or until a new line has happened to move on to the next thing. So for example, it said please enter your first character. I've typed in A. It hasn't actually given it to the program yet. It won't give it to the program until I push enter. And similarly, if you have a printf without a new line, that won't actually print to the terminal until it has another printf with a new line. So if your program crashes between your printf and something with a new line, you won't see that printf. You will see this a lot with loops. Yep, so it asked me for A, I typed in A, pressed enter, and then it took that enter as the second character. So I wanted to ignore the enter. How could I get it to ignore the enter that I type? What if I just did this here? So I'm saying C1, the integer C1 equals GetChar. So get a character, put it into C1, then GetChar, just get a character. Then C2 equals GetChar, get a character, put it into C2. Clear. DCC. Cool, so A and B. Yes, now we've got first is A, second is B. So does the reason for this make sense? GetChar will get literally the character that is typed, the next character that is typed. If that's an enter, that'll get an enter. If it's a space, it'll get a space. Like, the thing that you type is going to be the thing that goes next into GetChar. Whereas scanf, on the other hand, scanf is pretty chill and flexible, and it'll ignore things like enters and spaces. Maybe let's rewrite this with scanf. So how do I do my scanf? I want to scan in something and put it into something. So how am I going to scan the character in? %C, yep. If we printf with %C, then we scan with %C. And I want to scan that into C1. Let's do the same thing down here. Scanf C2. Comment out this one here. So now this code just has scanf one character, scanf another character. Print out the characters. And I claim that this will work. Okay. This is warning me that my C1 is an int, and it's expecting a char. Let's see if it works anyway. It didn't quite do what I wanted. How strange. Maybe I'll make them chars. If you're sitting there bored, have a think about this. Why would it have given me this really big number and then also A? How could that possibly have happened that it's A and also this giant number? And if you're not sitting there bored, let's look at running it again. So A, okay, I lied to you. Scanf %C will also scan on the next character that you type. If I do 2 characters there, maybe. A, B. Okay. Well, we tried. Turns out scanf also will just get a character like GetChart does, so you do need some way to explicitly catch that new line that you're typing that you don't want to be there. Cool. Hopefully that makes sense. Minimize. I think that was all of my GetChar stuff for this slide. So the thing down at the bottom, how can we fix it? The answer to that was add another GetChar after this one here to capture the new line. Cool. And so another important sort of topic or concept to understand is the end of input. So if you're scanning something in and there's nothing to scan in, like bad things will happen, right? If you try to scan something in and there's nothing to scan in, then how does it scan it in? So if you're doing something like reading from a file, you can read from files in C. We'll look at that at some point soon. If you're reading from a file and you hit the end of the file, right? Like if your file, notepad, hello, just says hello, and then that's the whole file. If you try and keep scanning after you've read the hello, there is nothing there. That's the end of the file. It can't scan anything more in, right? There is nothing more to scan in. And so scanf and GetChar both won't work if there's no more input because what do they scan? GetChar returns a special value to indicate that no more input is available. And we call this value EOF. So GetChar will return EOF if there is no more input. And this is hash defined in, I think, stdio.h. But basically, what this means is you can use EOF like this in your program. Someone else has hash defined it already to mean whatever GetChar will return. And how could we check this with scanf is another good question to ask. Conveniently, I have the code right here. So one thing we can do, reading until end of input with GetChar. So we say, here's our character. While our character is not in the file, print out, we've read this character, and then get another character in. And so this will loop around and around and around, reading characters until the character is end of file, and then it will stop. Whereas with with scanf, scanf returns the number of items that it's scanned in. And so we can chuck this in a loop while scanf into the number gives us 1. You've entered the number. I will chuck these into VLab. Alt-tab. Goodbye code. Hello code. So So let's start out by doing this with GetChart. So using GetChart to get input until EOF. And now let's I get the feeling this won't work because when it hits the end of input, it's not going to look for any more input, but we'll see. So this is the code from before. We have an int called C. We get the character into C. This needs to be an int, not a character, because characters can be ASCII values, but end of file is not an ASCII value. In this case, I believe it's -1, which you can't store in a character. There's no ASCII value -1. This character is red. The ASCII code is this. So scanf. Nope, starts with GetCha, scanf, EOF. By the way, the thing that's happening here, I'm doing what's called tab completion. Hopefully I've talked about this before. You hit tab and it beeps. You hit tab a lot of times and it tells you these are all the possible things that you could type here. So for example, all of these various things. The one I want is GetCha, scanf, EOF. So I can start typing like G for GetCha, hit tab a bunch more times. These are my choices here. So I want it to be, it's completed it to GetChart because it knows they all start with GetChar. But I want to have GetChar, scanf, EOF. So if I type the dash, the only choice now is this one here. That's the only one that fits. So tab completion is your friend. Compiling. Cool. Cool. So using GetChar to get input until EOF. And what this should do, if I can make it fit. So it's going to start out by getting a character. So I'll type in a character. I'll type in A. It said A is being read, ASCII code is 97. I hit enter, so it read and enter. ASCII code is 10. Sure, it's fine. I'll type in hello. There we go, it's read HELLO, and then the new line that I hit at the end. So I can type a whole bunch of stuff, blah, blah, blah. So what it's doing each time, I type in some characters and then I push enter. When I push enter, it sends it to the program. So shh. When I'm typing this in, like as I'm typing this in right now, it's not going to the program. When I push enter, it does go to the program. The program then does this GetChar. It's not EOF, it's a character, prints it out, GetChar, and so on. Does anyone know how I can simulate EOF in Linux in a terminal? Because if it's reading from a file, it will hit the end of the file, right? But there is no end of file when I'm typing things because I could just type forever. So it turns out we can type this thing called Control-D. And Control-D will simulate an end of file. And you can see what's happened here. It's read the thing, ASCII code is 10. Now it's printed out using scanf, so this loop has terminated because it hit the EOF. And so, looking at our scanf code, I've got an int num. While scanf %d into num is equal to 1, printf you enter the number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Gosh, the computer's so good at this. That's cool. Changes all my numbers to that number. Interesting. So how am I going to make this stop? Scanf returns the number of things successfully read. So if it doesn't read something successfully, then it'll stop. So what could I type here to make it not read something successfully? You've got sort of two choices. We could type in a letter, ASDF. ASDF is not a number, and so the program's ended. I could also type in the EOF from before. So Control-D sends EOF, and EOF is not a number, so scanf ends. Cool. Does that all make sense so far? Okay. So, thinking back to strings. Ooh, those buttons don't work. That's cool. Ah, I broke everything. This is Nan. I have Nan slides. Don't push buttons, you guys. Everything breaks. Let's try that again. Whoosh. Cool, and so I said before, strings are an array of characters. So hopefully you remember arrays. I'm going to zoom out a bit. Arrays are a series of boxes with a common type or next to each other. So box, 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 a bunch of boxes all glued together. So we looked at int arrays. Int myArray square brackets 10 equals curly bracket 0. So this means the thing is called myArray. The type is int array of size 10. And we set everything to be 0 to start out with. And so we get this array here, 10 things glued together, all with 0 in them. And then we can put values into it. So like myArray 0 equals 3. This 0 is 3. myArray 5 is 17. This one is 17. Right, and so character arrays are the same, except with characters. So when I say char myArray 10 equals 0, I've made myself an array of characters. And when I say something like myArray 0 equals 65, I can put the letter 60, or the number 65 into myArray 0. Do you remember what that letter was for 65? Yep, capital A. So this array now starts with capital A. And then I could put into myArray 5 equals 70, so then there's a 70 in here. That'd be A, B, C, D, E. Capital E. So let's play around with this a bit. Char array. Cool. So I can make myself a character array like this. I can put some values into it. And let's print everything out. So let's make a loop. While I is less than 10, printf %d, my array I plus plus. So what this should do, goes through our loop, goes through 10 times from 0 to 9, printing out the thing in my array I. So my array 0, my array 1, my array 2, and so on. Beautifully timed. Okay. And so nothing interesting has happened, right? I've just made an array. It's of type character rather than int. It's got some characters in it rather than ints. I've printed them out as ints, so nothing's really happened that's noteworthy. And then I've hit end of array. So let's print them out as characters instead. So now I'm just printing out a character rather than int. So printing it out, reading it, interpreting it as a character rather than int. Cool, so I've got A, some blank spaces, F, some blank places, end of array. That's pretty cool. What if I wanted to chuck my Andrew values from before? Let's do find and replace. Replace, put char, circle bracket with my array, square bracket, oh man. I equals. Yeah, this is going to work. It's going to work. Not that one, not that one, not that one, not that one, not that one. Yes. Okay, cool. So I will put this into an array with a loop, because we like loops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14. This isn't going to work. Okay. I cannot make the array be filled like that. Let's then go for a shorter version. My array 1 equals n, my array 2 equals d. The shorter version of Andrew, of course, is and. Why don't I just, because we don't learn malloc until week 7. No. So, okay, my array is now 3 big, it's just going to say and. Cool, save, clear, compile, run. Okay, something has happened here. What has happened here? Have a think about this for 1 moment while I find something in my bag. So remember, I changed the size of the array to be smaller so that it would only contain the 3 letters for and, but something bad has happened. So what's the bad thing that's happened? It's gone runtime error, index 3 is out of bounds for type char 3. So in this loop, right, this loop is going through until 10, but I've changed this one to be 3. And this is why hash defines are nice. So does this make sense? I need to make my loop go to a smaller number if my array is smaller. Cool, A and D, end of array. Everything is good. So there's this other thing we can do. We can print out arrays a character at a time, or a number at a time, right? But strings are this special thing where we can also print out the whole string in one go. Do I have a slide for this? No. Cool. So rather than %c for character, if I want to print a string, what do you think it's going to be? %s, yes, another time where it actually makes sense. So what I've got here, rather than printing out each character one at a time, A and D, I'm printing out the whole string at once. So I'm going to say print out A and D. Or don't do that and make the window go over there instead. Okay, cool, whatever. Let's save this as char away %s. I will just save the old version as well. This one here. Char array %s. Cool, and I'll delete this stuff. Okay, so I claim %s will print out the whole string. The whole string is A and D. This may or may not work. This hopefully won't work. It worked. Okay. So, it worked because I'm compiling the wrong file. Char array %s. I'll just call it char array %s.c. Now let's try. Cool, it didn't work. So we've got this error happening here. Runtime error, illegal array, pointer, or other operation. Array execution stopped here, printf %s my array. So this is nice. This is DCC holding a hand and saying, hey, you can't do that. You're doing something wrong. Please don't do that. So let's just live dangerously and not use DCC. Let's use GCC. Okay. Cool. So what we've got here, GCC has gone, I don't care you're doing something wrong. Like, it's fine. Go ahead and do that. So it's printed out our and. It's printed out the array we had, and then it's also printed out all of this other stuff. Like, what is going on there? This is crazy. That's not in my array. It's completely and utterly crazy. This is a good time to swap to the tablet. Okay, this should still be projecting to this one here. Ah, it is. Fantastic. Record. So I said that arrays, character arrays are just boxes glued together, right? So I'll make it be 5 big for now. A and D. Is that readable? Both in terms of size and my handwriting, is that good? Can anybody not read it and wants me to do something better? Cool, okay. So, currently my array looks like this, right? It's 3 boxes, A and D. When we have int arrays, that's fine, I have the 3 things. I have to know how big my array is, right? Shh. With an int array, like you can't go beyond the end of the array, that's not valid. So for an int array, we say, oh, we know this array is 3 long, for example. We hash define our array size and we don't go more than array size. But with strings, like, it's possible that we don't know how big it'll be. If I'm scanning in, if I'm working with your name, right? My name, Andrew, is A-N-D-R-E-W, 6 long. Someone who's got a really long name, really long first name, anyone? Who's got a really short first name? Someone say your name? Tom. Tom, cool, Tom. So Tom is much shorter than Andrew, and so we can't just say this, you know, here's our array, here's our name array. It happens to be the length for Andrew or Tom, depending on who it is. Like, we have to know how long it is before we can do that. Shh. And so with strings, we do this cool thing, where we have an extra box on the end, and in this, we put what's called a null terminator. I might make that be a different color. Red. Cool, this is a null terminator, so that's a 0 with a backslash in front. So like how we can do \n for new line, \0 for null. Cool, so strings are arrays of characters with a null terminator at the end. And so this means that it works for any length. So we can have our array be this size. If we have Andrew in this, just duplicate this. Oh, don't do that. Cool. So if we have Andrew in this, we would say Andrew, and then we'd chuck the null terminator in there to say this is the end of the name Andrew. And then all of this extra space would just be ignored because we've hit the end of the name. Shh. Whereas if we had Tom, T-O-M, I'm guessing, we would then have the null terminator after the end of Tom. And so if we were printing this out with Printf, or if we were somehow working through this ourselves, we would know that the name Andrew here is going to be 6 long, and the name Tom here is going to be 3 long. And so then we would know to stop at this spot. So does that make sense so far? Strings are character arrays with an extra bit on the end. The extra bit on the end is the null terminator saying this is where you stop. Good? Bad? Good? Good? Question?
If you had like int variable and then a string attached to it, so like Andrew attached to int 0, how do you access each individual each letter inside of the string?
What do you mean Andrew attached to int 0? Andrew is a word instead of numbers?
Okay, no, so if you have a list of names, how do you access the letter inside of each?
Let's hold that thought and talk about that a bit later on, or maybe tomorrow. Is that okay? It's a good question, but it's like a bigger question. So given that I've said that an array is, a string is a character array that ends with a null terminator, why would this have printed out this much and then stopped? So I reckon this was just printing whatever else happened to be in memory after that array. And then it hit a null terminator in memory. Conveniently, in memory, there happened to be a null terminator, and that's when it stopped. So if I run it multiple times, we can see the contents of the memory change each time. And eventually, sometimes it'll be shorter. No, okay, it always ends in that Y. One of the times it was shorter. So it just so happened that this time it had and all this random crap and then a null terminator earlier on. But we don't want to have that because that sucks. So we can just go my array 3 equals \0 null terminator. Let's make this be 10. Cool, so does this make sense? I've chucked a null terminator at the end of my letters at the end of the place where I want it to stop, and that has become my string. Clear this, compile, run. Cool, so it's printed out and then a null terminator.
Why does that work even though my array 3 is longer than the array 2?
Because I made array size be 10. Yeah, the question was, why does that work if it's still 3? I made it be 10. See, hash defines are great. You can sneakily change them without students noticing. And so if I made this be and row 2, 3, 4, 5, 6, this will now print out Andrew. So we've seen this is the same as this here, 0, 1, 2, 3, 4, 5, 6. And then if I wanted to print Tom, let's even just overwrite this. So let's just go, okay, Andrew, you can go away. Let's instead put in Tom T O M null terminator. So what's in my array? When I run this, the array contains Andrew and then the null terminator, right? When I do this here, I'm replacing the first part of Andrew with Tom. I'll copy this, move it down here. So I've overridden my Andrew. I'll use a different color. The A has become a T for Tom. The N has become an O. The D has become an N. The R has become a null terminator. So what will this print out now? I've changed the array. I've replaced A and D with T, O, M, and then I've put a null terminator in after the M. So what should this print out? Tom. Yeah, it should print out Tom, even though in the rest of the array the Andrew is still there. It will stop printing when it hits that null terminator. Cool, and indeed it has. End of array. And just to prove it to you, let's just make a function to print out the array. Void print array. My array is a character array of array size. While I is less than array size. I plus plus. Array %d is equal to %d. So what this is going to print out, it's going to print out the array at index %d, I, is equal to this number here, which is going to be my array I, and that's the character this, which is also going to be my array I. Let's put that there. Print array, oh, I put it in already, cool. Oh, it's just a printf. Okay, what have I forgotten to do here? What do I always forget to do? Why am I going to get a compile error here? Let's try it and see. Warning, implicit declaration of function print array is invalid in C99, aka Andrew, you forgot your prototype again. Let's try that again. Cool, it works. Char array. So it prints out Andrew, right? I've filled in the array with Andrew like I had in the red before in the diagram. A and D, REW, null terminator. So we can see the array has A and D, REW, null terminator. It happens to have the value of 0. Then we go and we change it over to have Tom. So we make it be TOM in the first part and then the null terminator. And you can see right here, it's got TOM, then the null terminator, and then the rest of Andrew. But it's happily ignoring this because Tom is got the null terminator at the end, and so it just goes, cool, I've hit the end of the string, I'm happy, I'm going to move on, goodbye. Does that make sense? One person nodded, it must make sense. So this sort of tangentially leads on to an interesting question. As a side note, what if we don't initialize our array? So what do I mean by initialize? When we initialize like a variable, we give it an initial value, right? So Initializing an array is the same thing. I've done that here. I've said fill the array with the zeros. And so there's syntax you can use to fill an array with zeros. You can't fill it with another number. Like this will fill it with 1 and then a whole bunch of zeros. So it won't do all ones, but this will always do all zeros. But what happens if I don't initialize my array? Uninitialized array. So let's go int my array size. Then let's go print out my array. It's just numbers now, not characters. Get rid of all this. Get rid of this. So you can't print an int array with %s because it's not null terminated string. So I've made myself an array. It's called myArray size. It prints out the array. So what's going to be in here? I haven't initialized it yet, so what's going to be in here? Do we know what's going to be in here for sure? So we don't know because we haven't put anything in there. It could have anything in it. We don't know yet. I'll chuck this one back to this. Whew. So what's going to happen? It's going to call the print array function. It's going to print out the contents of the array, but we don't know what they will be. Something may or may not happen. That is the wrong thing to compile. Ah, yes, thank you. It's no longer a char array, it's an int array. Very good. Could have changed that one too. Okay, well, I accidentally typed a slash, so that ruined the beautiful appearance. So array 0 has this thing here, array 1 has this thing here. This is weird, right? This is not what it should have. This is not useful numbers. If we were trying to do something like sum the values in the array, we would get a very weird answer here. Shh. And so this is what we refer to as an uninitialized array. These are uninitialized values. They happen to have the stuff that was there lying around in memory in that spot of memory beforehand. This is bad if you're doing something where it matters what the values are. Like if you're doing the fun articles thing from this week, right? Has anybody, let me check again. How many of you have looked at the lab for this week? So I say fun articles and you vaguely know what I mean, okay? So those of you who don't know, you have an array of ints. And if you don't initialize that array of ints and you pass it to one of the functions, strange things will happen. And so in order to catch this happening, we can add an extra flag to DCC. So I'll just do this in full screen. So normal DCC -o blah blah.c. We can also add a -- valgrind. It should compile just the same, but when we run it this time, it gives us a runtime error, uninitialized variable access. You might have seen this in Autotest. Autotest runs with this flag. Autotest catches when you do this. So you might find, oh, it works fine on my computer, it doesn't work on the Autotest, what's wrong? It might be this. Think about whether your array is uninitialized. But this is DCC, helpfully having an extra thing plugged in, like helpfully having an extra thing called valgrind helping out, which says, hey, you've accessed an uninitialized variable, you shouldn't do that. Be quiet, please. Be quiet for like 3 more minutes, you can do it. So it's saying, it calls a thing called valgrind, and valgrind will it'll manipulate how your code works underneath to make it notice when you've done something uninitialized. So it'll set it to something specific maybe and do something. But long story short, it will tell you you've accessed something uninitialized and it will fail the Autotest and it'll tell you there's a problem, right? So if you get this when you run Autotests, you probably haven't initialized your array. And it's useful that it tells us this because otherwise we get these random values here, which don't make any sense in our code. I think that's about it. Cool, yep, and that's just the compile line for it there. So before we pack up, are there any more questions? Yes. What's %s? String. Okay, the question was what's %s with scanf? String. Cool, well if you have any more questions, feel free to come down the front and talk to me. Otherwise, good luck in your toots and labs this week. Remember, if you have a Friday Tute Lab, you should go to another one this week. There's one running tomorrow during the lecture, or go to any other lab that suits you. Otherwise, see you tomorrow.